Hey guys, welcome back to Pine Hollow Auto Diagnostics. Today I'm working in the field. We got this 2001 Chrysler Town and Country, and the customer complaint is the front blower motor doesn't work. So let's try it out. Got nothing there. Now the rear blower, you can hear that it works. So front blower indeed does not work. So first plan of attack here, I'm going to pull up a wiring diagram and see what the easiest thing to check is. Usually I start either at a blower motor relay or at the blower motor resistor, depending on what's easier to get to. Because on this system, it's the automatic climate control. So instead of just a regular resistor, there's a like a smart module. So this thing sends a pulse width modulated signal to the module, and that controls the current going to the blower motor. So it's kind of similar to like a Chevy truck that I've done recently. Maybe I'll link to that in the description. So let's get to it. So when it comes to diagnosing any electrical circuit, it pays to do your homework ahead of time. So I printed out just one page here of this front blower motor schematic, and let's take a quick look at it. So we have a front blower motor relay, and that is in the intelligent power module under the hood. It is controlled by the front control module. I don't quite know if that's the same as the auto temperature control. Supposedly it's inside the IPM, so maybe it's not. But anyways, we go through a fuse down here. This is our front blower power module. So this is kind of instead of like a smart resistor board. So anyways, we have a fused motor relay output. Let's just say that's the feed. Again, Chrysler diagrams, I mean the labeling is usually way off. Then our head unit, the knobs, this is a low current, probably pulse modulated signal to this smart module. Then we have our ground, and these two pins control the current to the blower motor. Now I don't know why it says rear blower high speed blower motor. This is all wrong, but all we're interested in is the wiring colors. Hopefully those are right. So this thing lives behind the glove box, so it should be easy to get to. And from here we can check everything. We can check the feed, ground, the pulse width modulated signal from our controller, and then obviously the front blower motor itself. We can even unplug it, send it direct power and ground, see if it works. So let's find this guy. Alright, we're inside the van, swung down the glove box, and here it is. So it looks like this is going to be a gravy train, right? I wish all manufacturers made their components this easily accessible. So what do we want to start with? First I want to maybe connect the test light between this dark blue, which is a feed, and the black and orange, which is a ground. So right there, dark blue, black and orange, and just see if we have power on that. And then we can experiment with the blower motor. We just pop this thing out for easier access. Alright, I have my new and improved test light connected across the power and ground. So let's turn the key on. We have a feed. Excellent. So our relay works. Now we also want to check this when it's plugged in, because maybe the test light's not bright enough, or should we use a load pro? I don't know. So let me plug this back in and back probe this. Alright, now we have it plugged in and back probed with our light in place. Turn the key on. Oh, make sure your connections are good. Alright, let's turn the blower on, see what happens. Nothing's happening here. Turn on full blast. Nothing's going on. Alright. So at this point, let's measure the control. That little skinny blue, light blue wire, which comes from our blower control, dark blue, light blue. And that we need a scope for because it's pulse width modulated. We could use a voltmeter. Yeah, let's do that. Let's stay primitive for now. I don't feel like firing up the Verus in this cold. But and if we don't see a change with the voltmeter, then we can hook up our scope. Alright, we got our meter hooked up. So the positive lead is on that middle terminal right there. The negative lead is just piggybacked off of our ground right here. So that's the cool thing about these connectors. I actually salvaged them off of some fried Verus leads to hook up our test light. So no more alligator clips, falling off. This is nice and reliable. So anyways, let's see, key off. We have 0 volts. Key on. We have 8.1 volts, 8.8 volts, somewhere around there. I'm going to turn the blower up and look what's happening to our reading here. See, it's kind of blinking. Can't really, something's changing, but I think we need a scope to see the actual signal here. We can put it on a frequency setting and turn it up. Yeah, I don't know. 8.6. Yeah, I mean, you can't really make anything of that, so let me get the scope out. Alright, we got the Verus fired up. Turn the key on. We have power here. We're hooked up to there. Turn the fan on. Let's see, we're not making a connection here. What's going on? There we go. You still have to double check your connections, Alright, so there's our pulse width modulated signal. Let's drop the time base. There we go. Let's turn the fan up. See what happens to our duty cycle. Cool. So we have control. Key off. 0. Key on. Wave from, low to high. I don't know how low it's supposed to drop, but from 2 to 12 volts. So our fan should be operational. There's nothing wrong with our control module. So this is the only 100% accurate way to test one of these. You can't use a voltmeter because you'll just get a really weird signal. We can also, just for kicks, go to our graphing multimeter and we can graph our duty cycle. Alright, so we're starting out with, let's see here, there's a live reading, 27% with the fan off all the way. As we increase our fan to maximum, we get 90% duty cycle. Decrease it. Alright, so we've ruled out the control module. We've ruled out our powers and grounds. All we need to do now is send direct, power and ground to this blower motor and verify that the motor works, and then we can confidently replace this smart module. And guys, we've only been here for a little while, and I'm seeing my battery voltage here, 10.7. Our test light is getting kind of dim. Let me just verify the voltage with my voltmeter. So I just unplug the leads from our Varus. Let's see, plug them in here. 9.2. So the the Varus calibration's off, like you saw in a previous video, or maybe you haven't. But anyways, battery's dead. We need a jump pack on this thing because, or start it up, let it charge up, because we can't really do definitive testing with the battery drained. Here's what the battery looks like. I might recommend a new battery for this lady. We got our pocket power jump starter. Let's fire this thing up and let it charge a little bit. Sweet. Save the day once again. This thing's pretty awesome. Alright, now we have battery voltage. Our test light is nice and bright. I like that. Again, our blower motor does not work. So let's continue our checks with the car running. Alright, so here's a quick way to test your blower motor using the feed that's already coming here from that relay. So first we have to figure out, since on our diagram we just have two wires coming from the module to the blower motor. We don't know if there's a constant power and it's ground side switched, or if there's a constant ground and it's power side switched. So the way to tell is, again, use your test light. When I left the ground connected and I moved the other wire to this green on the blower motor feed, and see, we light up bright. So we have a constant feed on the blower motor through the module there. So all we need to do to check the blower motor is to connect these two pins, the ground from here to here, and if the blower motor works, we can confidently replace the module here. Alright, so let's do that. Alright, so I just have a fused wire here with some male spade connectors. So now I'm back probing the ground on the blower motor. So all we need to do is provide a ground, and this motor should work. Here we go. Sweet. Nothing wrong with the motor. Let me do a quick amp check, amp draw measurement with our amp clamp when we bypass this thing. So let's re-zero that. We'll hook it on our, check this out, guys. So look at our amp scale, if you can see that through the glare. I'm going to touch it on the ground. Wow, 25 amps. That's not good. It's a little much, isn't it? Let's try again. 26 amps. So that is why you do an amp check on your blower motor. So basically, if the blower motor is drawing too much current, we're going to fry our module. And if we replace the module, it'll work for a while, but it will die prematurely. So I can give this lady a quote, on just the module. And, this is kind of an old van. She's just keeping it going for a little while. So if she wants to fix it right, we're going to have to get a new blower motor as well. There's no way around it. So that's you know, that's how far you have to take the diagnosis to guarantee a repair, because otherwise, you know, you replace a part and it burns up a year down the road, especially if it's an aftermarket unit. That's just, you know, not good business. They won't be happy if like, oh, you just fixed it and then, you know, it breaks. So we have to be very thorough and cover all our bases here. So let me look up some prices, labor times, see how easy or hard it is to change out this blower motor, and I'll give her a quote and see what she decides to do. Alright, see you guys for now.